Okay, welcome back. We're looking at question 3. Now I just want to take the three letters R, S and T, because they're the three letters involved, and I want to get into this without spending ages figuring out what they're telling me. So we're not going to use the double letter things. We just say, coming at this question, it tells me the length RS is 7. The angle at T is 23 degrees. The angle at R is 58 degrees. And you can probably figure out what they're going to ask us, ST, and they are indeed. Let's call it X. Okay, so I'm going to start off with X equals. Now here's a trick for you. That's a distance. We want distance on top at the far side. So this is your other pair. So go 7 over a sine of 23 degrees. Because if as a pair they must always be top and bottom, times the sine of 58 degrees time my opposite number. So consider him to be literally your opposite number. So these are, and then its opposite, then that's 7 is upstairs. Okay, I'll leave it at that and we'll do that. Fraction bar. Also, quick prediction, this has to be bigger than 7. Can you see why? Because this is bigger, opposite a bigger angle than 7 is opposite. Okay, so we know X is going to be bigger than 7. And we go from there. And that makes sense because sine of 58 over sine 23, sine of 58 over sine 23 is bigger than 1. Good. 7 sine 58 over sine 23 equals 15.2 centimeters or whatever. Yeah, centimeters. Okay. Moving on to question 4. In the triangle MNP, MP is 13. Notice I couldn't care less about the x and y axis. There's no such thing. We're back in geometry as such. The angle at N is 35. And the angle at P is 58 degrees. So they're going to ask us to find this. Find NP? Whoa, yeah. Okay, they're not. They're going to ask us to find this. So what you do is, so this is curious, lovely question. So the first thing you do is you find this angle, if you want to use the sine rule. Otherwise you may end up using the cosine rule, but that's not going to work either, because the cosine rule needs two sides and an angle. So that's very interesting. Yeah. So yeah, you'd have to go via this angle. So I'm going to just rest my brain and go 180 minus 58 minus 35. Now please do that in one single calculation if you're doing it. By all means work it out mentally, but don't get it wrong if you're working it out mentally. 87 degrees, and if you do get it wrong, still practice your mental work if you insist. That's cool, but use a calculator in the exam if you don't want to risk human error. You might be very good at mental maths, and of course we can see here that's 80, that's 93, yeah. Huh? That's 80, that's 93, 87, yeah. So 93 is slightly above. Come on, I'm talking rubbish here. Come on, we'll move on with the problem. So we're trying to do this pretty quickly now. We'd say x is proportional to 13. So basically, let's clear out what I don't want. Where's my pair? That's my pair. I don't want that 58 anymore. He was an unknown opposite side, and he's still unknown. I couldn't care less about him. So x is to 13, that's for sure. Okay, now x is to 13. These are two sides. And it would have been x over sine 87, so I'll have a sine 87 here. And I'll have a sine of 35 here. Now let's not forget the other two steps. Let's make the prediction. 87 is bigger than 35. Therefore, x is bigger than 13. Now let's make sure we're on our way here. 87 is bigger than 35, therefore this will be bigger because these are rising functions, and that makes them, that sine of 87 is always bigger than sine of 35 because we're within 90 degrees. That's interesting. That brings the question of, oh, that's fantastic because these are all obtuse. So that brings in the question of, so what's going on if we're out here? Oh, why can't I ask more interesting questions? Okay, we'll have to ask a few more interesting questions ourselves in a moment. So we have this 13 sine. Anyway, we didn't have to, but what we could do is just not have that safety net of the prediction, sine of 35. Or we can do better than that. I'll have an idea now for you in a second. Okay, so x equals 22.6, and that's a distance. Let's be careful here. This was bigger than that as expected. Okay, I want to show you that idea I had. So let's make up a question here with an obtuse triangle. Let's make this angle here. What's 1945? 135. Okay, let's make this 155 degrees. Okay, let's put in his opposite number. Say it's 19. And let's put in an angle here. Now, 25 is the top I can do. I can't go to 25. Okay, I keep it well less than 25. Let's make it 11 degrees. Okay. So let's call this x and ask what's the x. So x is to 19. Distance is to distance. X and sine 11 go hand in hand. So the sine 11 would be down here, but he can come up here now. Sine 11. And 19 should have his opposite number down below, and he will have when I go sine of 155. But what I have to be careful of is discussing the length. Or do I? Oh, it's complete rubbish what I was saying. Okay? Because, of course, the bigger the angle right up to 180 degrees keeps making this opposite side bigger. Okay? So it's okay to have intuitions and think you had a mathematical idea, and because it's a conjecture. It's a sort of a conjecture in your head. And just by exploring it and finding out, no, my example was ridiculous. Okay? And so it comes back to the syllabus. The syllabus has a theorem in it. The G study. Here it is right here. In any triangle, suppose that AC length, some side length is bigger than another side length. Then the corresponding angles have that relationship, and it doesn't say, and it isn't true that that's only true for acute angles. That's always true. So I had a little, disastrous thought there, but it's all very well, and that'll work out. I'll leave you do that in the calculator. Okay. So what are we saying? X has to be way less than 19. Okay, I'll do it in the calculator. Hope you're not being lazy now. You did it ahead of me. Sine 19 sine 11. Down we go to the sine of 155. Okay, equals 8.6. And is it true? Is x less than 19? Yes, it is, and that's fine. That passes the test of what we're looking for. Okay, we'll keep going. Question 5. Did I do question 5? I've done question 5, so we'll move on to question 6 and so on later on.